Today I'm going to go over identifying and representing functions. And the first definition that we're going to talk about is just a relation. A relation is a set of ordered pairs. And ordered pairs or a relation can be expressed in 4 different ways. It can be expressed just as ordered pairs. Just like with the parentheses, like x comma y. Mapping, and we'll talk about mapping today. A table, you can put the ordered pairs in a table, or a graph. You can graph those ordered pairs. So we're going to represent the following relation shown in the coordinate plane as a set of ordered pairs, a table, and mapping. So we're going to identify these 1, 2, 3, 4, 5, 6, 7 points. So the first point right here, I'm going to go left to right across the graph, would be negative 1, 2, 3, 4. This point right here would be at negative 5, 1. And then this point right here would be negative 3, negative 2. Then we have this point down here would be negative 2, negative 1, 2, 3, 4, 5. So negative 2, negative 5. Then the center point right here is 0, 0. And then moving across, this point right here would be 2, 2. And then this point would be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That would be 4, 6. And then this last point right here would be 1, 2, 3, 4, 5, and then negative 2. So 5, negative 2. Okay, and then to put these in a table, I'm just going to list the x coordinates here and their corresponding y values here. I'm going to try to do these from least to greatest, so on my x values. So I'm going to start with negative 5, 1. I guess they're already in least to greatest because I listed them from left to right. So negative 3, 2, negative 2, negative 5, 0, 0, 2, 2, 4, 6, and 5, negative 2. Mapping, you're going to list your x coordinates in this circle or oval. So I'm going to list which we also call these the x values, the domain values, 0, 2, 4, 5. And then the y values, 1. Okay, I'm going to put these in least to greatest. So put negative 5, negative 2, 0, 1, 2, and there's also a 6. Okay. So what we want to do on mapping is we're going to look at this ordered pair negative 5, 1. So I'm going to take negative 5 and I'm going to connect it to 1. Negative 5, 1 connects to 1. Negative 3 pairs with negative 2. I'm just drawing a line connecting them. Negative 2, negative 5, 0, 0, 2, 2, 4, 6, and then 5 also pairs with negative 2. And that's mapping. Now, a function is a special, specific type of relation in which none of the first coordinates are repeated. So all the x are paired. Let's spell this right. Paired with exactly one y value. X is paired with exactly one y. So we're going to look at this set of ordered pairs and determine if it's a function. And the best way or the easiest way is you're looking at the x values and you're making sure that none of the x values are repeated. So you have a 2, a 3, a 6, and a -1. And none of them are repeated, so this would be yes, this is a function. So you've probably heard of a function machine. It's an input. So for every input, there's exactly one output. It's another way of thinking of what a function is. For every input, there is one output. So when you think of an equation, if you put in a value for the x, then you'll get exactly one value for the y. Okay, now I'm going to go to the next page. I did switch pages. So let's look at this set of ordered pairs to determine if it's a function or not. So I'm going to look at the x values and make sure for every x there's only one y. So if I input a 1, a 9 comes out. If I input, if -2 is my input, a 5 is the output. If I input a 1, well, right here on the first one, the 9 was the output. Right here I'm inputting 1 again and getting a different output. So that breaks the rule of a function because right here I have two different output values for the same input value. So one is repeated right here and here. So this would be no because 1 repeats. And that's an x value. So the x value can't repeat. And then these are different, but this is the reason that this is not a function again is because the 1 repeats right here, here, and here. Let me erase these. Okay. So you can also look at a mapping to determine if it's a function or not. So if you look at this, these are our input values and these are our output values. So if you notice 2 is being paired with 12. Or if I input a 2, I get my output as a 12, but also I have an output of -3 to -3. So right here you can see because there's 2 output values for this one input value, that breaks the rule of a function. So this would be no because 2 repeats. Or 2 is being paired with 2 different y values. Is another way of thinking of that. If we wrote these ordered pairs down, 2, 12, 2, -3, and then 1, 5, that's okay. 1 is only being paired with 5. And then 0 is being paired with 0. And -1 is being paired with 5. Now it's okay that 5 is being paired with -1 and +1. They can have the same output value, but this input value 1 can't have 2 output values. So the way you can tell on a mapping is if you have 2 lines coming out of this mapping, 2 lines coming out of this input, then it's not a function. And then you can also tell from a vertical line test that if it's a function or not, or you can do what's called a vertical line test to tell if a graph is a function. If you move across the graph, you want to make sure that the x value is not repeated, or no, if I do imaginary lines, I can only intersect that line at one time. So, or you want to make sure none of the points are on top of each other. So this would be yes, this is a function. Because these vertical lines are only intersecting the point at one place. Each dot only intersects the line one time. Right here on my graph, if I do vertical lines across there, it's like moving across the graph, every time I draw a vertical line, the graph's only hitting the vertical line at one place. So this would also be a function. Let me draw a picture of something that's not a function. So if I drew it like this, and I drew a vertical line down, this graph would not be a function because it's intersecting this vertical line test at two places. For this x value, it has two output values. So for this x value, it has an output here and here. So this would be a no. And that's how you determine if a graph is a function. All right, thanks. Let me